Are you interested in the field of data science and want to get started with a Python project? Well, this White House News Analysis project is for you. In this two-part tutorial, you will be learning how to use web scraping and data visualization to analyze the White House news publications using Python packages such as requests, beautiful soup, pandas, matplotlib, and more. Without further ado, let's get started. In this White House News Analysis project, you will be using Python, web scraping, and data science to analyze and visualize the news articles released on the White House website. In particular, I will be using the White House website of the Trump administration as an example, the link to which will be in the description of this video. This is not only because Trump was the president back when I first made this project myself, but also due to the interesting data present on this website. As you can see here, each news article has not only the type of the article, such as executive order, statements and release, and presidential memoranda associated with it, but also an issue that the news article is about, such as law and justice, veterans, foreign policy, etc., as well as the date on which the article was released. This will give us plenty of interesting data to work with, but of course, this is just an example project to get you started with data science. The knowledge that you will gain in this tutorial will allow you to scrape more interesting websites and analyze more interesting data. This project tutorial is going to be split into two parts. In part 1, which is the video that you're watching right now, you're going to be using web scraping to scrape the White House website and extract useful information from the website's source code. Next time, you'll be using the data that we get today to do data analysis and visualization. Before we get started writing today's part of the program, let's first talk about web scraping and the two packages that we'll need for this part of our project. As you know, the internet is a huge place with so much useful data. But sometimes there is so much data on the web that it is difficult for us humans to easily access and understand. Now, web scraping programs here can help. These are scripts that access the web and extract data from websites. We can use the data that we get for many different things, such as analysis and visualization. When we, as humans, access a web page in a web browser, the browser uses something called HTTP, which stands for Hypertext Transfer Protocol, to transfer information from the web servers hosting the websites to our computers. In Python, we can use the requests library to send HTTP requests. To install this package, because it is not part of the standard Python installation, you can just copy this command right here, and then open up command prompt on your computer. You'll see a window that looks like this, and you can just paste this command right here and press enter. Because I already have the request library installed, I see something that says requirement already satisfied. You should see the downloading and installing progress bars, and then it will tell you that it's installed. If you see some error that says pip is not recognized as a command, then I will link a video to solve that in the upper right hand corner of this video. Using HTTP, we can get the HTML, which stands for Hypertext Markup Language, source code of a web page, but HTML code can also be very tedious for humans to read. Luckily, we have the Python package called Beautiful Soup, which can parse messy HTML so we can easily extract just the data that we need. And here's the command to installing Beautiful Soup, which is pip install Beautiful Soup 4. You can copy this and go back to your command prompt window, pasting it in and hit enter. Again, you should see Beautiful Soup 4 being installed, and I already have this installed, so I see requirement already satisfied. And now you have everything you need to start working on this project. I will be using Sublime Text to write this project, but you can feel free to use whatever code editor that you normally use to write your Python programs. Here I have made a folder called White House News Analysis, in which we have a Python file main.py. Let's start off by importing the two libraries that we just installed. So we have requests, which we can import with the line import requests. For Beautiful Soup, we want to write from BS4, standing for Beautiful Soup 4, import the class beautiful soup. Notice how the B and the S are both capitalized. The requests library, once again, is used to send HTTP requests to web servers. In particular, we want to use the GET request, and we can use the requests library's GET method to do so. So if I write request.get, we need to pass in the link that we're trying to send a request to. So we can just copy this link and paste it in here. Let's just print out whatever we get from the GET request. And we'll see we get a response object with a status code 200. 200 is the HTTP status code for success. And if I change the link a little bit to an invalid one, so news, let's say news 1, and run this, we'll see a response, but this time with a status code of 404 not found. So let's change it back to the correct version of the link. And instead of printing this out, I'm going to store this in a variable called response. And let's print out response.content. This, you'll see, is the HTML source code for this web page right here. It's very difficult to read, much less to parse and extract data from. Luckily, we have the beautiful soup library to do it for us. And the way we do that is we can make a new beautiful soup object called soup. And this is going to be a new beautiful soup object with 2 parameters. So the first parameter that it's going to take is the HTML code. So we can just pass in response.content. And the second parameter is the parser we want to use to parse the HTML. So we want to pass in html.parser. And let's print out soup.prettify. This method is going to format the HTML source code in a way that's more easy for us to read as humans. So we'll see the HTML is now nicely indented and we can read the code in a nicer format. If I scroll to the top, let's just look at an example of an HTML element. If I take a look, let's take a look at this element right here. So this A tag, this A element is a link, and actually this link right here, we can click on it to go to a different page. And this A element has a class called navLink. It has an href, which is the link that it's going to take us to, and then it has a text, economy. If we're going to look for, let's say, the word economy in this entire HTML source code, we can use Beautiful Soup to do that. So we're looking for this element right here. How can we do that? Well, I can print out soup.find, and then the find method takes what we're looking for. We're looking in this case for an A element, an element with an A tags. So we're looking for an A, and there are so many A's in this entire document that Beautiful Soup won't know which one you're talking about. So we have to specify something more specifically. We're looking for the one whose class is nav__link. So we can copy this and specify that we're looking for the one with class underscore is equal to nav__link. And the reason why we add an underscore here, normally we wouldn't do that for other attributes, but for this one, we need that because class is a Python keyword, so it will break our code. So we have to add an underscore right here. Let's print this out, and we'll see an A element with class navLink, and is the one for economy. If we just want the word economy, we can just write .text.text, and we'll see the word economy printed out. Now you may wonder, because if you go back, if we go back in our code and look at the prettified version of our HTML again, if I scroll up a little bit to where it was, we'll see that there are actually more than one A elements in the entire source code with the class navLink. For example, this one, national security, it's also an A element with a class of navLink. So why did this code find economy and not national security? Well, it turns out that this A element right here is the first one in the entire document. So .find will look for the first one. If we want to look for the second one, we can use the find all method. So we're looking for all of the A elements in the entire source code whose class attribute has a value of navLink. So let's specify this is going to give us a list of all the elements. And let's look for the second one, so index 1. And this will give us national security. Or we can just print out, let's say, the length of this list. So we have 53 elements in the entire HTML code, which are A elements and whose class attribute has a value of nav link. That's a lot, and it would probably, without Beautiful Soup, we would not be able to extract that information as quickly. So that is the two methods that we're going to be mainly using to extract information. Let's take a look at our web page again. We're looking for these news articles, and in particular, we're looking for the data of each of these articles. We won't be going inside of these articles and looking through those texts. Instead, we'll just be looking in the outline form, as you can see right now. Let's take a look at the information that we want. So for each of these, we have the title. We have the title of the news article. And then we have the type. So it could be statements or releases, it could be executive orders, etc. And then we have the date on which the article is released. And then we have, for some of them, the issue type that the article is dealing with. So those are all valuable information that we can extract from this web page. How can we do that? Well, let's take a look at the HTML source code of this web page again. You can do that by writing it in your code, or you can right-click in your web browser and clicking on the inspect button right here. And this will show you the rendered form of the HTML document. So you can click on this button on the top left of the pop-up, and then hovering over anything will show you the HTML code responsible for that. So we can see that this whole thing is inside of an article element, as you can see right here. So this is one article, and this is another article. This is another one. So each of these news articles, all the information lives inside of an article HTML element. So we can look through all of the articles on this HTML web page and find information that way. We can do that with a for loop. So let's write for each article in soup.findAll. So we're looking through the list of all the articles in the entire source code. And let's print out the article. Well, let's see. What can we print out just to print out something? So let's print out the class of the article tag. So let's print out article class. So we can access the class attribute of that article element by putting it inside of a square brackets and then the quotation marks. So printing this out, we'll see a list. So each of these will be a list. It will be presidential action results, briefing statement, etc. Right? So these are the presidential action results, briefing statement results. So perfect. Now we've accessed this web page and printed out the classes of these article tags. So what more can we do? If we're looking for, let's say, this line right here, we want to see the title of this one. How can we do that? Well, let's take a look at the HTML responsible for this line. We'll see that this is inside of an A tag, but this A element is actually not that specific. It only has an href, which is the link, so it's unique anyway. So we want to look for the h2 element outside of it. So the h2 element is a little bit more specific. We're going to be looking for an h2 element with the class presidential action title. So I'm going to copy this. And in here, I'm going to print out soup.find, and I'm going to be looking for an h2 element with a class of this. Let's print this out. For the first one, we have presidential action title, and then we have executive order on the revocation of executive order 13770. And for the second one, we have the same thing. Oh, I made a mistake. So here, instead of using soup.find, we want to look for article.find. So that way we're looking for the first h2 with this class in the article tag. So in each of these articles instead of in the entire HTML element or the entire HTML document. Running this again, we'll see at the very top, we have the h2 element inside of which we have the A element. And this is the correct one. And then for the second one, we have a presidential action title. We have an A tag again, and this is another article. And some of these, though, we have none. Why is that? Well, if you look back at the HTML document again, each of these is actually different. This article, we have presidential action. So inside of the result, the H2 is going to have presidential action underscore underscore title. This one right here has a class briefing statement. If you look inside the H2, you'll see that the H2 has a class of briefing statement title. So what we can do here is we can use the first value of our class for the article and then add underscore underscore title to it. So let's take a look at how we can do that. So we first need the, let's call it article class. So we want to find for this one, it would be briefing statement. So we're looking for the first class of the article tag. For this one, it would be presidential action. So we can call article class is equal to article class. And since we only need the first one and it's a list, we can use indexing to find the 0th index one. And then let's print out article class. So we see all of these printed out. We have the articles for presidential action, briefing statement, etc. To find the title, we just need to add the word underscore underscore title to it. So we can write title is equal to soup, or sorry, in this case, article dot find. We're looking for an H2 with class of, let's use an F string here instead of using string concatenation. So we have class or article class underscore underscore title. And then let's print out text. And we have to print that out. So let's print out title. And we will see we have the articles titles printed out nicely in this output. So we have now extracted all the titles from the HTML document. So we have all of these ones. Now let's look for the types. So executive orders, statements and releases, and so on. So how can we do that? Well, once again, we want to look for what is this HTML. So we can see that this is a p tag, a paragraph, and the class is presidential action underscore underscore type. Now you may guess that if we look at this one right here, it will be a class briefing statement underscore underscore type. So it's the same thing as the title. We just need to add underscore underscore type instead of underscore underscore title. So we can just duplicate this and let's call it issue. Or no, this one is type. So let's call it type. But because type is a Python function, just to avoid any potential name conflicts, let's add an underscore to the end. So article.find, this time we're looking for a paragraph. And then instead of title, we're looking for type. Let's print out type. So we see executive orders, statements and releases, executive orders, and so on. But notice how we have some random white space around all of these strings. So let's just use the .strip method to remove all that unnecessary white space. So we have a nicer formatted strings printed out here. Now, let's take a look at how we can extract the issues. So the issues are like law and justice, veterans, and so on. So we can once again look for the HTML element. This is going to be an A tag, but this one is not very specific. So let's look for the one above it. So it's going to be a paragraph, a P tag with class issue flag. So it's a paragraph with this class right here. So issue is equal to article.find P class is equal to this right here. And let's just print out issue. Now you will notice that the first one is none because in the first article, in the article element, there is no paragraph whose class is issue flag because there is no issue in this, or there's no issue data associated with this article. So how can we handle that? Because some of them have that issue data and some of them don't. So we can check, is it none? If this is none, then we don't want to find the text for it because that's going to throw us an error. If I just print out .text here, we'll see an attribute error thrown saying that none type has no attribute text because this is none. none does not have a text attribute. So what we can do is we can use a ternary operator in this case. So issue is equal to issue.text.strip, because there's also going to be some white space. So issue.text.strip if issue is not none. Otherwise, we'll just assign it to maybe not unknown, maybe other, or something like that. Doesn't really matter what it's called, but we're essentially checking if issue is not none. So if there is some data associated with the issue of the article, then we will assign issue.text.strip to the issue variable. Otherwise, we'll assign other to the issue variable. So this time, we'll see other. So this one does not have any data associated with its issue. And then we have law and justice, veterans, foreign policy, etc. Beautiful. So this is all now working. I'll give you a little bit of challenge to look for how you can access the date information of each article, because it's pretty easy. You can just go through the process again, and then when you're done, come back and check on this video again. So here is how you can do that. You can click on this button again and look for the time, which you can see is nicely inside of a time element. So the time element, we have the data inside of it. So we can do what we have been doing before. So the date is equal to article.find. We're looking for the time element, and let's just do text.strip instead. Actually, let's just do this for all of them. So .text.strip, just to make sure we don't have any random white space after we extract our data. Let's print out date. And we see the different dates on which the articles are published printed out. Perfect. So now we have all the information that we need. How can we access this information after the program has run? Because all of these are currently stored inside of variables, but variables disappear after our program ends. So how can we access this later in our analysis? Well, what we can do is we can make, let's just do this right here. So let's make a data dictionary, which has, let's call this title. It will have 4 lists. So these lists are going to store the different data that we extracted. This is going to be type. This is going to be issue. This is going to be date. So right now, these are empty lists. And every time we find a title, a type, an issue, and a date, we want to say data title. Let's just use the .append method to add the title to it. And the same thing for the type, for the issue, for the date, and for type, we need the underscore right here because we call it type underscore here. So after all of this, we can print out data. And we will see a dictionary printed out. The dictionary, we have a key title, and then we have a list that goes on and on to about here. So this is the list of all the titles in the first page of our HTML, or of our news page. And then type, we have all of these different types. Issue, we have what we saw just a moment ago, and then the dates are the dates on which the articles are published. So that's perfect. Now let's take a look at the web page again. Let me close this. This is one page. I would feel like the White House News web page will probably have more than just one page. And in fact, if you look down here, you'll see that we have 910 pages. So if I go to page 2, we have more data to scrape. So how can we do that? Well, if you take a look at, let's just go to page 2 again. The news web page is organized in this way. So we have whitehouse.archives.gov. This is the archived version, by the way. So this is not the current White House website. And you can use this even a long time after the presidency for that president has ended. So /news/page/2. So if I change this to, let's say, /30, it will take me to the 30th page of the news articles. So we can look for more of these data. So we want to automate our program to do that itself. So what we can do is we can make a while loop to keep scraping all the pages. So let's make a variable called page num, the page that is currently scraping. Let's set it to 1. That's the first page. While true, it's going to do all of these things. Maybe not the print data, but all the other ones. And maybe we don't need this. Let's move it up so that we have just data made initially, and then we keep on adding to it. So page num is initially 1, and let's print out scraping page and then page num. So let's print out what page we're scraping right now. And then the link will be modified, so it will be news/page/page num again, and we have to make this an f string. And I think that is pretty much all we need after we add some more things right here. So let's add, so first of all, we need page num plus equals 1, so we don't keep scraping page 1 over and over again. And something else we can add is we can tell our program to pause a little bit after each page has been scraped. So we don't keep sending request after request after request to the same server, which can potentially crash that server. So we can import the time module. And then here, after we increment page num, we can do time.sleep. Let's sleep for 0.5 seconds, which should be enough anyway. And then we'll go on to the next page after that. Let's take a look at if I run this program. So what if I run not from page 1? Let's start from page 909. If I run this program, we'll see it will throw an error after a little bit. So page 909, 9010, and it will say none type object has no attribute text. And that is because after 910, if I go to page 911, it will not have any news articles for us to scrape. It's a 404 error. So what we can do is we can check if our response, or no, it will be after this. So if response.status code is not equal to 200, that means we have reached the end of our web pages. And then we can just print out, let's say, ended. And then let's break out of our while loop. And yes, right now we have 910 pages and this website won't be changed anymore. So you can just tell it to scrape with a for loop 910 times. But let's say you're scraping another website and it's being constantly updated. It may have 2,000 pages tomorrow or 5,000. You won't know. So you can use this method to make sure that it's going to end at the very last page instead of a predefined page. So if I run this now, it will scrape to 910. Oh, look, it's still not working. So what do we need to do? So let's take a look at the 910th page just to see what is happening. Okay, so okay, I see what it did. So we thought that every one of them would have the type associated with it, but it turns out that one of them, at least one of them, does not have the type associated with it. So we got to do what we did for the issue again for the type. So I will just duplicate this up here. Let's call this type underscore is equal to type underscore dot text dot strip. If not, if type, okay, that will work. So now if I run this, it should work now. 909, oh boy, it's not working. It's not none, otherwise it will be other. So for this one, we can't have this here. Cool, this should work. And we see all of this data printed out. On 911, it's actually ending, so it didn't scrape anything on that page, which is printed out just to make sure we see what the last page is going to be. And we see this nicely formatted, well, not nicely formatted, but nicely extracted data from the web page or web pages of the White House News website. And you can start it on page 1. But after you spend so much time running this program and having it scrape 910 pages, the data is still going to be lost after the program ends. So how can we keep the data, let's say, on our computer so we can have access to it next time when we work on the analysis of this data? Well, we're going to use a module or a package that we haven't really talked about, and it's pretty data science focused, so it's not part of web scraping, but we're going to need the pandas library, which you can import by the statement import pandas as pd after you write the command pip install pandas in your command prompt. So you can see I already have requirement already satisfied, so you want to just write pip install pandas in your command prompt. And at the end, I won't explain this too much. It's essentially going to save our data to a local file. So let's just print out, or let's just make a new variable, df is equal to pd.dataframe data. And we're going to save this to a document called data.csv. And before we do that, just to make sure, let's print out the length of data title as well as the other elements, just to make sure. Instead of printing out all the data, let's print out the length of the lists. So we know whether we got the same number of titles as we did types, as issues, as dates. Now those two lines is we're making a data frame object for the data. Now a data frame in pandas is essentially a table of data. And then we're going to use the df.tocsv file. We're going to save that data frame into a CSV file, a comma separated value file. It's essentially something like Google Sheets or Excel. You just save this to your local computer. So I'm going to run this program now, and after the program has finished running, there will be a new file on the side called data.csv, which contains all the data that we scraped off of the website. So let's just run this for now, and we'll have it going, and I'll be back once it's finished doing its job. So now we can see in the output of our program, we can see that the length of our different lists are the same. So we have the same number of titles as we do types, issues, and dates. That means that we have a very good data collection process, and we're able to find the correct data. And we can also see on the left side, we have the data.csv file. It's a pretty big file with a lot of data in it. So it's essentially, you can think about this as a table. It's a table with 4 columns: title, type, issue, and date. And then this is the title. And this article is in executive order. It is unknown what the issue is about, and it's published on January 20th, 2021. So you can also open this file in Excel or Google Sheets if you upload it. And next time, in the next video of this tutorial, we'll be looking at how we can use the data in this file to do data analysis and visualization. And that is the end of part 1 of the White House News Analysis project on the Future Programmer YouTube channel. In addition to collecting big data as shown in this video, you can also use web scraping to do a ton of other things, such as tracking the price of a product that you're considering to purchase, using just the knowledge that you gained from this video. If you found this tutorial to be helpful, please consider subscribing down below to the Future Programmer YouTube channel. And if you don't want to miss the next part of this project tutorial, make sure to hit that notification bell. With that said, thank you very much for watching this video, and I hope to see you in more data science and general programming tutorials.